Now we are going to look for the second phenomena, that is the photoelectric effect, right. So what does this photoelectric effect means actually? Photo means light, right, and electric effect means that is the production of electricity. So this thing we are going to observe in this phenomena, that is the photoelectric effect. So the first I am going to explain the phenomena, then I will just read out the definitions for you. See, suppose I have a metal here, let us say this is a metal surface, this is a metal. It is connected by means of wire to a battery like this. So, and here is an ammeter also which can actually record the current. So what we see that when light strikes the surface, let us say light is striking the surface, light is falling on the surface. So when light strikes the surface, then what happens? We see that electrons are emitted and they start flowing towards the positive. As you can see, this is negative and the positive terminal. So when the light is falling, the electrons get emitted and they are flowing towards the positive terminal. This is what is a photoelectric effect. That is the ejection of electrons, that means removal of electrons when light of suitable frequency strikes the surface. So when light is striking, this is ejected. So this is the photoelectric effect. But now we have actually seen three kind of observations in this photoelectric effect. First is that for the ejection, any light cannot cause ejection of electron. Any light cannot cause ejection of electrons. There has to be light of suitable frequency. There has to be light of suitable frequency to cause ejection. Right, so that means suitable frequency of light is needed for the ejection of electrons, and particularly that suitable frequency, what is being given a special name, that is the threshold frequency. That is called as threshold frequency. As you know, frequency is noted by nu. When it is threshold, it is noted by nu naught. So we have seen that any light which falls on the metal surface cannot cause an ejection. There has to be a light of a minimum frequency equal to threshold frequency, then only the ejection is going to take place. And this threshold frequency is different for different metals, and generally it is written as nu naught. Second observation, what is seen is that velocity of electron depends upon the frequency. Velocity means they possess kinetic energy, as we have seen that electrons are emitted and they are moving also. So the kinetic energy of electron depends upon the frequency. That means, see, the ejection can occur. Suppose the light of suitable frequency strikes the surface, that means the ejection will occur, right, if the frequency is suitable. But if the frequency is more than threshold frequency, because the whole light which is falling, then the frequency equal to threshold frequency is being used in the ejection, and the leftover frequency is given to the electron as kinetic energy. So we can say that velocity or kinetic energy depends upon the frequency. Third, we have seen that number of electrons ejected depend upon intensity of light. Number of electrons ejected depends upon how long this light is allowed to fall on the metal surface. So this is what we have seen, the photoelectric effect. So now this is actually a photoelectric effect, right? So now if we apply electromagnetic wave theory to this thing, then electromagnetic wave theory believes in continuous generation of energy, as you all know. Right, but here what you are seeing that when the light is not of suitable frequency, then it doesn't matter that how long it is falling on the surface, there is no ejection is going to take place, right. But if the light has the frequency equal to threshold, then it will cause an ejection, but there will be no movement of electron. But If the frequency is more than the threshold frequency, then the electron is ejected also and it is moving also. So that means these things what we have seen is not according to an electromagnetic wave theory which believes in the continuous generation of energy. This process is actually looking like a discontinuous process. So we need a theory to explain which do not believe in a continuous generation of energy, rather it believes in a discontinuous generation of energy. So this could not be explained by the the electromagnetic wave theory. So this is about the photoelectric effect. And one more thing, the metal which is best suited for photoelectric effect is that which has minimum ionization energy. So cesium is best suited for photoelectric effect because there the electrons are not so tightly bounded. So when the light of suitable frequency falls, that means less frequency can cause an easy ejection. So this is about the photoelectric effect.